what is really the key message from this project. And this project is called Blox, or We Are Blox, is the official term or the official name or brand of this application going to market soon. And what is it about? Well, it's really about the hype in cryptocurrencies and blockchains. And basically the investors of this company, BTC Direct is the founder company. They are being very successful on the Dutch market, and they've built up a trust relationship with their customers selling bitcoins. They have a web platform. All the trades they do on the website, they actually go directly into a crypto exchange. And now they wanted to push the envelope a little bit further by having a mobile app, which can be easily accessible from the smartphone. Also, the idea was that the order should not be executed on the crypto exchange, but would be actually executed immediately as a sort of managed crypto wallet. And they're very ambitious. They want to go full scale, global, starting in the Netherlands, obviously. What they notice is that new crypto exchanges, I don't know, who owns crypto coins? Can you raise your hand if you... a little bit, few hands. There is, for example, there's this crypto exchange called Binance, which went live about a year ago or so, and they attracted so much traffic and so much transaction volume. I mean, everybody was really surprised by how quickly this market can grow. So this is going to be a modern bank. It's going to integrate with the crypto exchanges, etc. A little bit about myself. I work for Trifork. I'm a software architect, hands-on programmer, senior dev, whatever you want to call it. We have a lot of partners in this project. AxonIQ, obviously. Sprite Cloud is helping us with testing. Container Solution is another Trifork company which is good in Kubernetes and Google Cloud in this stuff which we use. And Spring Boot is the base for the microservice application, and I probably forget quite a few. So yeah, and I mentioned a few of these things already. So an app, quick onboarding, know your customer. So we have identity verification. We do all this stuff, payment verification, bank account verification. I mentioned we leverage existing crypto marks. So we want to connect to we have a lot of integration points to a lot of crypto exchanges, like Kraken and Bitstamp, which are popular ones. We use managed wallets. I mentioned that as well. And it's also a trading platform, so what they want to do is, if they sell a lot of coins, obviously they need to leverage that and be able to pay that out, or if they get a lot of euros in, they should be able to get the coins for that. So, like a typical bank, they would take positions and balances on crypto exchanges, or have liquidity in terms of coins in the blockchains to be able to pay out, and it's actually mandated by regulation as well. And this is a little bit how the app would look like. Now, in terms of the architecture and the requirements for building this thing, so, well, first of all, it's event-driven by nature. Things happen, right? Prices change in the crypto exchanges. There's order books. Blockchain transactions are being validated. Bank transactions arrive. So, by nature, it's very event-driven. It's also a rapidly changing domain. We need to be agile. Agility is quite an important requirement here. And not to forget scale. So we want to scale this thing. If you look at the architecture, we have a broker application, so many brokers could actually hook on to the trading platform, connections to crypto exchanges, connections to banks, and connections to blockchains. We want to scale this thing, think global, think, what do you say, X million users, maybe, I don't know, 500 million users. I don't know how successful they're going to be, but we're ready for that. Non-functional, okay, distributed, microservices was one of the things which came up when we wanted to build this thing. It's getting more and more into our DNA, and well, it was really a logical choice. Running on cloud, yeah, we didn't want to use any of the existing infrastructure they already have. We want to also take benefit of all the advantages of running in the cloud environment, having cloud-native services and leveraging Kubernetes. Auditing and event sourcing was absolutely a key requirement. So every transaction, everything happening in the system there should be some proof of where the origin of the transaction came from or where the origin of the data came from for that transaction. Obviously, continuous integration, continuous deployment, which is challenging, I can tell you, if you do that in combination with Google Cloud and microservices. But we set up quite a nice setup with GitLab. It was challenging because GitLab hasn't been too stable during the development of the project. But, well, we managed. Obviously, security and privacy are important parameters as well. Yeah, so broker apps, I think I mentioned that a little bit. We have a couple of APIs to request market information, to request quotes, and to actually place orders. And then on the back-end APIs, or the functions we support is to actually place order on crypto exchanges, to be able to manage liquidity, that we actually join all the order books, so we have the best pricing from all the exchanges on the market, and obviously be able to execute transactions on the blockchains as well. We zoom in a little bit. The platform will have domains, DDD. If you put on the DDD glasses, then we will have you know, these kind of subdomains, markets, quotes, products, pricing, etc. And Axon framework in the middle, tying everything together. Zoom in one more step. If you look at one of those subdomains, you will see that we build up the modules, as I call them, but you know, we could call them microservices. There's a laser in this thing, yeah. So there would be the yellow one would be query, the blue one would be account or aggregate, taking care of the commands. Also passing on the events to the event store. And then we would have an API type module, typical REST controller from Spring Boot. We use Swagger also. Everybody uses Swagger, I know, it's pretty cool. We actually generate the code from Swagger. We generate our REST API model and controllers from Swagger. And I think if you look at the whole system as a whole, I actually have an architecture diagram with all the subdomains. And the setup is quite similar for all of them. This is one which is for creating accounts and products. And the requirements really are, yeah, okay, so we know Axon, right? We need to be able to fire, oops, that was not what I wanted to do. We need to be able to fire commands. We need to be able to process the events. And we want to ask the system in the query model what the situation is. And we apply this pattern across the board. So if you zoom in, so typically one of these subdomains will have 1, 2, 3 pods, Kubernetes pods or microservices running. And if you have multiple replicas, so we will have typical subdomain will have 6 pods running for duplication. Now, if you look at the messaging requirements, this is actually, I'm not going to talk too much about it because this should be well known. You know, Axon has the ability to process commands exactly once. Events are publish, subscribe type communication. And for queries, you want to load balance or scatter gather type queries. It's actually a slide from Axon itself. So what are your options? If you need this if you have those messaging requirements, what are the options? You can go out of the box from Axon framework. You would get well, you can use simple async bus. Well, we are distributed with microservices, so that's not an option. Then you can go distributed with JGroup, Spring Cloud, and for messaging you could do, or for events you could use AMQP or Kafka, and so on and so on. I think this is well known as well, actually. So yeah, I call it the do-it-yourself type of bus structure or messaging structure. That's the way we started off the project, and one of the first things we did was to play around with the distributed command bus. We used console for service discovery. It says here, yeah, now we have 2 because actually, if you use console in Kubernetes, Kubernetes also has a discovery mechanism. There's even a Spring Cloud Kubernetes project you can use to use that as a Spring Cloud implementation of that. So that means if you use console, that means you actually have 2. Then on the event bus, typically we thought, well, we're going to use Rabbit. Queries, we didn't think too much about it initially. Probably REST calls. This was difficult. Implementing console, we got a lot of issues. I even reported a few bugs. Steven in the back, hey, remember? Anyway, that was hard, you know. It felt tough and it didn't feel right. And then Frans Bouhier from AxonIQ showed up at the office and said, I want to show you guys something. He showed us AxonHub. And I mean, you know, we can look at the slides and go to I was sold immediately because, well, I'm going to explain a little bit more why it's super valuable. But basically, it unified all the messaging types required, easy to configure, nice UI, gRPC, so it's HTTP2, really ready for the future, what's going on. One cool thing is with gRPC, you can actually have two-way data communication streaming on both sides, server type streaming, which comes handy. If you, for example, want to do subscription queries, I don't know if somebody mentioned that. In Axon, you can do subscription query, and it's, I think Frans told me actually that's the only way to do it right now is to use AxonHub, and we actually use that a lot. Subscription queries are super cool. I have a few slides on it, but I'm afraid I'm going to have to skip them time-wise. Yeah, all the routing is configured automatically, etc. So what does it really mean for us? I mean, if you go for the alternative infrastructure setup with the things I mentioned, considering the experience we already had with console, I mean, I calculated maybe this is like 8 man weeks or something. I don't know, probably more. Just setting it up, right? This is just to set it up. On AxonHub, so we use Kubernetes. So we, I don't know, who's familiar with Helm? Does anybody know Helm? Yeah, a few hands. That's pretty cool. We are very fond of Helm. Basically, it allows you to package a Kubernetes application. It has a definition, well, the typical Kubernetes manifest files are pre-configured. There's a website or there is a mechanism to actually download them and deploy them on Kubernetes. So AxonHub didn't have a Helm chart, or there was an initial version from France, I can't remember exactly. But that's what we're using. So we have this Helm chart and we had to create that or polish it up. And then actually test how it works, upgrades, redeployments, and add the AxonHub requirement, which is really one dependency in our Gradle file. And that was it. You know, we were up and running 2 weeks time, having tested it and really running traffic. From an operational perspective, that's actually even more interesting than the time you spend on just setting it up, because typically that's a one-off. So we have a cleaner architecture, I believe. We don't have overlapping discovery mechanisms. One thing I really, really like is we don't have this thing here. We don't have a lot of moving parts, like console and Rabbit. But if you multiply that by the number of environments, we deploy the way we do CI/CD. Whenever we push a branch, we actually deploy a complete namespace in Kubernetes, and we have the whole environment running. So I can do git checkout -b branch name, push, and then I will have a complete environment set up within a couple of minutes, running all the parts, running Axon, AxonHub, Swagger, everything we need. That's actually pretty cool, and I'd like to show that. Yeah, we don't need to manage queues and topics and vHOS and dead letter queues and all that stuff. So what actually happened is that we forgot about these things. You know, it's just there. You know, it all. What we think about when we develop code is how to apply patterns. You know, where do we put our query handlers? How do we solve a problem that we have an integration point and we want to trigger that we fetch data every 10 seconds or so? How do we do that in Axon? That's the way, you know, we're dealing with business logic, how we deal with our integrations, how do we schedule things happening. These are some of the patterns we use, and I'm not going to go into detail with it. But, you know, having a factory pattern, for example. When we produce a quote, typically in Axon, if you have an aggregate, you want to keep state, right? But for quote, we don't need state. We just, it's a one-off. We produce it, but we want to have the event in the system. So that's what we call a factory pattern. And there's a bunch of them, and it's probably not complete. Anyway, there's quite a few. And interesting to actually discover in your system what kind of patterns you use. And the next time you build a similar pattern, that you actually build it the same way and not differently, which also, one programmer would solve it that way, another one that way. That's a little bit my job as an architect, to see that we all build the stuff in the same way. How am I doing time-wise? I have no clue. Can somebody give me a hint? Minus 5, plus 5. All right, deployments. Yeah, I mentioned Kubernetes so much already. What's on this slide? Yeah, I mentioned that. I'm going to skip this one. Oh, this is a screenshot of our pipeline running. So basically, we have a build stage. That's a typical grader build stage. We run the unit test as well. So these are the list of the pods. Then we have a deploy environment stage. So this is where we actually deploy the Kubernetes. So this is where we run the Helm command for AxonDB, AxonHub, and Swagger. Then we actually deploy the actual microservices if they change. So the builds will actually skip if we detect that there is not been a code change. So it's a type of, it's like this mono repo. We use one single Git repo because, well, I mean, having so many Git repos for each microservice, some people say that sometimes. Like, oh, really? I don't know. We just keep it in one repo and we work with this way of only deploying what changed. And then we run all our API tests. We use Postman, Newman, I don't know if that's used. It's actually consuming the Swagger file we produce and does all the testing. And then finally, when we're done with this, depending on the branch, you will have a deploy to the next environment. So I guess this is a master branch. Yeah, that's it. Kube charts, I actually already mentioned some of that. So, well, here you see some of the logging when you actually deploy AxonHub through Helm chart or to Helm. So, what's interesting here? Well, it deploys, the setup is to have really a service, a stateful set. So AxonHub in Kubernetes has to be a stateful set. There is control data in AxonHub, which is stored in the Kubernetes persistent volume. So in order to, I mean, if it's not a stateful set, actually Kubernetes would wipe all the data. So in this case, we really need to keep the data. And then we have some ingress definition for, I guess that's the HTTP connection. And yeah, for gRPC, there are other ingress for gRPC, I'm not sure. And if you look in Google Cloud when it's deployed, or if you have your own Kubernetes set up, then you will see that all the pods will be up and running in this case on a specific cluster. So as I mentioned, when we push a branch, we actually have, we will have on the same cluster, but the names, oh, you see here, the namespace is really the master branch. But if we work on a feature branch, we work feature branch based, and this will be the feature branch name as the namespace. So the AxonHub, yeah, it says demo, but I'm just going to show you a few screens here. Who hasn't seen AxonHub actually in real life? Oh, quite a few people. You need to do something there. I haven't seen it. There's a workshop. Cool. What are we looking at here? I think we zoomed into one of the pods. The ledger query module. There's two of them running. These are registered queries, and these are the tracking event processors. There's a couple of them running, and there's a warning here which I was told has to do with how we store the token stores, if we share the database or not. But roughly this is how it looks like. So, what have we learned and what kind of improvements? Well, first of all, we are really super happy. We had some issues initially configuring the AxonHub and AxonDB in cluster mode on Kubernetes. I think the registration procedure, which is done, there's a small bash script or an API we can use which is used when you deploy that. So when one of the hubs, we have 3 hubs running, 3 hub instances, one of them comes up, then it actually registers itself. So it tells the cluster, hey, I'm here. I think that's a little bit cumbersome. It's a little bit took us some time to get working properly, but so that's an improvement. I think could be done. Another issue we have is that because sometimes some of the pods, when they start up, they actually want to fire a lot of commands, to have some initial data in the system. Now, it turns out that sometimes the command handler registration is just not that far, or the pod is still starting and it hasn't registered yet. So we have some timing issues here, that we want to use the system earlier than it's possible. So I actually had a chat with Franz, and we should be able to use the API to query whenever handlers are available. Something we need to dig a little bit more into. We have a lot of control type of events. I guess those are not real business value events, but they still show up in the system. So we actually use Axon and AxonHub to instruct a microservice to do something externally. We're not sure how to deal with those on the long run. I mean, they fill our event store and they kind of pollute the event store, and we don't want to replay them. So we're going to have to look up how we deal with that later on. Yeah, and I think we're still exploring. I think there's still a lot of stuff in AxonHub, AxonDB, and the framework as such that we will dig into and have more understanding of it. Right? So one slide about Trifork. So I work for Trifork. Alat actually hired me sometime. When was it? Last year? 2 years ago? I can't remember. Trifork it's the birthplace of Axon, where Alat started it, and we've done many projects with it, and including this project. And we really love Axon, and want to continue doing more projects with it. And I guess that was my last slide. And ready for change. That's the Blox expected to be launched soon. Vince in the back. We're going to go live and hopefully make a big dent in the crypto world. Make it happen. That's it from my side.